Hello, this is Carl Irwin with episode 6 of Hacking the Viewport, a series that I've been putting out, a tutorial series that is covering the options that we have with rendering in OpenGL and GLSL inside of the Blender Viewport. The last few episodes we've looked at a number of different things. We've stepped away from this original project for a couple of episodes to look at some new features that are being implemented in the Gooseberry build of Blender. We've also looked at the things that we have to do to use alpha transparency properly in Blender. We've looked at an add-on that helps us with the draw order issue in the viewport. But we're going to move our way back to this original project, and we're going to look more at the solid objects that you see inside of this scene here. So let me play back this original video. You can see we have this planetary sort of object here with some asteroids, a small asteroid field, and you can notice a number of things in the scene. We have this nebula figure which we looked at in episode 2, I believe, and some of the lens flare issues we've also looked at. We've looked at the star field as well, and compositing these types of images together inside of the viewport. But on the objects, you can see that there is some shading and some lighting that's going on. There's also ambient occlusion, which at the time that this project was made was not really possible inside of the viewport. However, since the addition of some of the new features in the Gooseberry build of Blender, you can now add some sorts of ambient occlusion and depth of field as well. That feature, as you've seen in the recent tutorials, is not perfect quite yet. It's still sort of in development, but very promising and very helpful. I want to show you how this was originally done, however, today. We're going to look at shadeless materials, and we're not going to use any lighting really in this scene. This scene used all shadeless materials when it was put together. There's no real lighting going on in here. And we're going to use a couple of hacks and tricks to get this ambient occlusion sort of look. And we're going to use methods that you may not even be thinking of. You may be aware of the vector paint system inside of Blender and the dirty vertex options that we have. We're not going to use that. That's not how this was done. That's also a very good option. We may look at that again at some point in the future. But we're going to use light masking, which we looked a little bit at in one of the early episodes, using actual point lights and light sources to provide three-dimensional volumetric sorts of masks in our scenes to change our materials. So anyway, let's get right into it. This is what we're going to make, hopefully, sort of. We're using the one of the more current versions of Blender 2.72, and this is a Gooseberry build. I also have enabled on here, we're not going to use it probably, but I have the GLSL tool kit that's being created, and I mentioned this on one of the earlier episodes, so please go back and look at that to find where you can get this at. But let's put together a planet here. We're going to change our view. We're going to go to the front. We will move our camera. We'll line it to the active camera to the view that we're looking at. We'll move it up on the Z-axis a little bit, and we're going to get rid of our default cube. We're not going to need that. We're going to get rid of the light that's in the scene. We're not going to need that either. I'm going to add an icosphere. We're not going to subdivide it right now. We're just going to leave it the way it is. I'll enlarge it just a little bit. And before we forget, let's enable our GLSL shading. So if we go to shading, under multi-texture, we'll change that to GLSL. Here you can see these new features, ambient occlusion, depth of field, that have been added to the Gooseberry build. If you want this Gooseberry build, you can get it at blender.org. Go to the development page, and you can find current builds, daily builds, and you'll find the Gooseberry builds under that page. They come out almost every single day. There's a new one. You don't need to use the Gooseberry build for what we're doing today. We're not going to use any of these features. Everything that we're going to do is on the current 2.72 build of Blender. Let's change our viewport to texture view. And we are going to add a couple of modifiers to our icosphere. Let's add a subdivision surface modifier. We're going to bump this up to 5. Not that it matters concerning the render versus view. We really are using the view because we're using the viewport, but we want that to be up to 5. And we're going to add a new material. Let's add a shadeless material. We don't have to change anything about it. We're going to be using textures on top of this material. And we're going to add let's add a texture very quickly so we can see what we're doing. So we'll add a new texture slot. We're going to use a shadeless texture. This is a pack of textures that I have put together. I created these in GIMP. You could do the same in Photoshop or whatever photo editor that you use. And these are textures that will represent different lighting and shadow type schemes. We're going to use one of these shadow schemes that we have here. I have 4 of them. And what this is it's a gradient from a black to alpha transparent, bottom to top, which would imply shadow on the bottom of our objects. And then I have 3 other versions of this, one with the gradient on the left, one with the gradient on the right, which would indicate shadow on the left or right. Also one with shadow on the top, gradient starting from the top for underlighting if we would need that in our scene. Let's grab onto one of these. And the way you use these is you're going to apply them much like you would a captured material. If you don't know what I'm talking about, I invite you to look at episode 5, where I talk briefly about matte caps. These are essentially matte caps that would be applied using the normal texture coordinates. We'll apply the normal texture coordinate, and we'll decrease the size a little bit on the X and Y axis, just 1 click to 0.9. And you can see that it implies that there's a shadow on the bottom of our object. This will help us to see our geometry a little bit as we do some of our modeling. So let's apply another modifier. We're going to apply a displacement modifier to this. We'll add a new texture. By default, it will apply an image texture. We want to change that to the old default, which used to be clouds. You can see that it gives us this bumpy kind of surface. Also, before we forget, we're going to change our shading to smooth for this object. Under the cloud texture, we're going to change our size. We're going to bump it up to, let's say, 1. And let's go to the colors, and we're going to add the ramp option. And we're going to bring our white, our high end, down quite a bit. And we'll see what happens as we move this. It will start to bring out the high end, and it creates kind of these divots in there. Actually, I'm going to go back to our size. We're going to decrease our size a little bit. Let's go down to 0.5. Maybe 0.75, which might be kind of closer to where we started. We're going to bring our dark side, the blacks, up a little bit. So let's increase those. And actually, I think I want to take the size back down to 0.5. Closer to the default that we had. And let's bring our whites up a little bit. Bring our blacks up a little bit. So what we're doing is we're creating this kind of a crevice sort of look. We can rotate this on the Z-axis, and you can see kind of what we've made here. Kind of similar to what we started with. Yeah, that looks okay. Let's maybe bring this down to 0.25, which may be really close to where we had it originally. Yeah, that's a little bit better. A few more crevices, more like what we had in the original. So this is how we model it. We're kind of done with this now. We've done all of the modeling that we need to for the planetary object, and we can rotate this in any direction. You see how this has been applied to it. So we have kind of a spherical object with a bunch of crevices and and gaping holes in it. And we start to see the formation of some shadow on it. Now, it's not realistic because you can see on the underside where we have some shadow, there's light, and that's because this is a normal map that's been applied to it. We're going to take care of that a little bit better here in a moment. Let's add a few more shadows to this. So we'll select our material. We'll make another texture slot, and we're going to just grab the same texture, the same bottom shadow texture. Again, we will apply this as a normal and normal mapping, and we'll decrease the size a little bit. And let's create one more texture. Underneath this, we'll apply another one, create a new slot, and we'll go back to our library of shadeless textures. We're going to grab one with a shadow on the right because our lighting is going to come more from the left-hand side. So let's open that up. And we will apply this also as a normal map. And we'll decrease the size a little bit. So now we've got kind of a lighting that's more to the upper left quadrant on our sphere, which is where our lighting is going to come from in the scene. We still have not solved our problems with the lighting, the interior lighting and the ambient occlusion. We'll do that shortly. Let's get some of the rest of the shadeless material set up here. We're going to bump our shadow textures down a little bit. And actually, for a while here, let's bring our subdivisions down a little bit just so we can move a little bit quicker. That's the benefit to using modifiers. And let's move down the other textures as well. So we'll take our shadow textures down, give us a little bit of room to work with. And on the top slot, let's add a rock texture. We're going to use this for a sort of bump mapping. So I found a couple of these rock textures on cgtextures.com. I think that's where I got this one from. And I think we'll need to bring up our mapping a little bit. This is a kind of repeating texture. We're going to apply this texture to a UV coordinate. And unfortunately, we haven't UV mapped this yet. So let's tab into edit mode. We'll go to the shading UV side, and we will select Smart UV Project. Click on OK. And I'll tab out of edit mode. You can see that now our texture has been applied. I think we want to increase the size a little bit, so let's increase it by 1.5 on the x-axis, 1.5 on the y-axis. And we're going to select also the geometry option for this texture, but we're going to decrease it to 0.1, so it's going to apply a little bit of bump mapping to it, and that will actually catch our shadeless lighting textures and apply them more realistically on our object. Let's add another texture to this, another shadeless texture. We'll go to our shadeless lighting pack again, and we're going to grab this texture here that has an orangey kind of color on the left and a bluish color on the right, dark color on the bottom. And this will again be applied sort of as a matte cap using normals, and it will imply a bluish light coming from the left, or rather an orange light coming from the upper left quadrant and a bluish light coming from the upper right. But we're going to decrease the lighting, or rather the color influence to 0.1. And we're going to change this to an add blend mode. And it's very subtle. You can't really notice it, but it does add a little bit to our scene. It gives us a little bit of an ambient lighting that looks a little bit contrasted on the left to the right. Orange on the left, blue on the right. And that looks good for now. Let's bring our shadows down a little bit more, a couple more spots to give ourselves a little bit more room to add a few more options here. We're going to add a highlight, sort of a backlight, a rim backlight look to this. So let's add another texture. And we'll go to our shadeless lighting pack again. And I'm going to grab this light here that it's listed as a Fresnel, and what this is used is if it was mapped as a normal map, it would apply kind of this light fall off that could be used as lighting, or it could be used as a mask or matte which would give the normals that are facing away from our camera view a white color, and the normals facing the camera would be more of a dark black color. So I'm going to select this one, and I will apply this as well as a normal map, and we will decrease the size a little bit as well. And you can see it gives us kind of this rim look to it. The shading shadow mats are covering it. You can see on the left and right. But I want to make it a little bit more stark, so we're going to move this, offset it a little bit. Let's see which way we need to go. We'll offset it on the x-axis 0.01, and then I will offset it, actually let's make that a little bit more, 0.05, and then we'll offset it on the y 0.05, and that will give us sort of this edge, this bright edge on the upper left quadrant. And we're going to apply this as an add mode. You can see what it does to our object. It adds a little bit more of a backlight, rim edge light sort of look to our object. Okay. Now we're going to snap our cursor to the selected right in the middle of it. And we're going to add another object. We will create a point light. Now, these are shadeless objects, so this point light really doesn't have an effect on our material. But we are going to add a sphere fall off, kind of a boundary to it, so that at 25 blender units, this would fall off and end. We're going to decrease the size down to 3. See where that puts us. Let's bring that up to 4. And we want to bring this so that it kind of comes to the edge. Let me bring that back down to 3 again. And I'm going to decrease the size of our icosphere. Before I do that, let me parent my point to the icosphere. It's going to go along with it. And I'm going to decrease the size of the icosphere so that it kind of comes to the edge, just to the edge of that light. And we'll go back to our light settings, and we're going to, let's bump the energy up to 2. Now we're going to go back to our icosphere and our material settings, and we're going to add another material. We have our first material that we made. We're going to call this a rock material. And then I'm going to add another material slot, and we'll add a new material. We're going to call this our light mask material. And this material is going to be shaded. It's not going to be shadeless. We're going to get rid of all the specularity. We're going to increase the intensity all the way up to 1. We're going to change the color all the way up to white, absolute white. And we're going to change the shade model from a Lambert to Fresnel. Now this is kind of a waxy sort of material so that light can pass through it. It does not cast shadow on itself. It will accept lights sort of in a subsurface scattered sort of way. And this is what the material that we want to use to apply a mask, the way we're going to. We're going to go back to our rock texture, and this is a very important texture that we just created, this light mask, because it can be used multiple times on many different objects in the same way in our scene. So this is not unique just to our planet. You could use this again later on for other objects. So you want to make sure that it has that light mask sort of name to it. It's not just associated with our planet. Go back to the rock texture. We're going to apply nodes to this one. You can see our material disappears. So we need to open up the node editor. And we'll open up our node editor. And in the node editor, we're going to apply our rock texture. And we'll see it reappear again. But we're going to apply another material to this node setup. We'll add a new material. And inside of this material, we will select our light mask. And if I apply the light mask to our material output, you'll see what happens here. So our light, interior light, that is parented to the planet is illuminating our Fresnel material from the inside out. we want to get this light fall off to be very bright, but we want it to fall out kind of at the rim, at the edge of the outside surface of our planet. So what we're going to do is we'll go to our point light settings, and we're going to increase the energy a little bit more to 3. And let's change our fall off from, I think right now it's at inverse square, to constant. See where that gets us. You can see it brightens it up a little bit. I'm going to select the icosphere, and I'm going to increase the size so that it kind of meets the edge a little bit better. You can see of our light. And let's increase the light setting a little bit more to 4. Let's see where that gets us. And that looks good for now. We'll go with that. Let's go to our icosphere again, and we want to go to our modifier stack. We're going to increase our subdivisions back to 5, just so we can see a little bit more clearly how this light mask is being applied. And let's go back to our node setup for the planet. And we're going to apply a color RGB curve. And we're going to apply this RGB curve to our rock material, bring this to the output. Now what we want to do is we want to generate what the interior shadow, the ambient occlusion shadow, is going to look like. So we're going to darken this way down. And I'm going to bring the highlights way down as well. Now I could just add a black color to this if we wanted to. But we want to retain a little bit of this interior highlight inside. So the best way to do that is to apply a curve in this way, because we want to see a little bit of that interior specularity sticking through our shadows, as if the light is bouncing around inside there. If we just apply a black color, then our ambient occlusion will just go to black. It won't seem quite as realistic. Okay, so this will be our interior shadow. It's mostly black. We are then going to apply a color mix node to this. And what we're going to do is we're going to mix together our shadow with our original rock texture. And we're going to use the light mask material as our factor input. So wherever we have the light color inside of our material shining, that will apply our dark material to our rock material. Okay, so what we want to do is we want to crank this up. We're going to go to our point, our light point. We're going to crank this up and control this by increasing the energy of our light. So let's move it up again to 5, 6, 7. Let's take it all the way up to 10. See where that gets us. So you can start to see how just the rim is illuminated now. Let's go all the way up to 15. And maybe even a little bit higher, maybe up to 20. So this might not be exactly like what we had in the original, but you can see the idea, what's happening here. Let's play around with maybe the fall-off type. We'll go to back to our original inverse square, see where that gets us. And that's not quite what we want. Let's go back to inverse linear, see kind of trial and error. Kind of like the constant the best. And maybe we can play around a little bit with our icosphere size a little bit more. Scale it down a little bit more. So we get to this to a point where it really looks just right. And maybe we want to let's add maybe a color to our light mask. So we'll add actually let's add an RGB curve to it. And on the curve we can maybe darken it a little bit. see how this helps. Yeah, I don't know how I like that. Maybe we can take the light end and bring it down a little bit. So you want to play around with this until you get it just right. It looks, you get just the right amount of detail in there, but you still see some clear ambient occlusion going on. Maybe we'll bring up the light in the middle. Maybe something like this. So we do see a little bit of that light bouncing around on the lower edge, but there we go. We can see now that we have a little bit of that light bouncing around in there, but we're getting clearer ambient occlusion inside of these crevices. So something like this. In addition to that, we could add some additional color correction if we wanted to change the color of this. Maybe add to the final output. Let's add another RGB curve. And on this curve, to the whole thing, let's apply a little bit of a contrast to bring out the highlight a little bit of this edge. So you get the idea of what we're doing here. And that looks good for now. We'll take that. So very, very similar to what we had. You want to play around with those settings until you get your material just right. Now, someone was claiming on a recent post that, you know, oh, this takes a whole lot of time to do a lot of setup in the front end, and you're really not saving any time in rendering versus using Cycles or some other render engine. I think that's foolish, quite frankly, because, you know, think about it. If you're using Cycles, you're spending just as much time getting your material set up just right. You know, I don't buy that at all. Using any other ray-traced render engine, you're using just as much time to get your materials perfect. You know, materials are materials, and you're going to spend time getting them just right. This is no different than that. The only difference in our node setup here is that we're considering more things. Rather than moving lights around in the scene, we're moving textures around on our materials in order to get our lighting. No different. In order to get our shadow just right, we're moving textures around versus moving lighting. You know, it's no different. In order to get the color right, we're still using the same kinds of node setup. So, again, it's no different. So I don't really buy that argument. But be aware that this is not some kind of series that is put out to put down Cycles or any other render engine. Cycles is just another ray-traced render engine. It is more versatile than the Blender internal. It is better than the Blender internal, therefore making it kind of the new standard for Blender. You know, but it is still a ray-traced render engine that renders incredibly high quality output, and because of that high quality output, you get a trade-off in time. What we're doing is we're pushing the limits of OpenGL to decrease our time but get a higher quality output from what you normally would get from just using the Blender game sorts of applications. These materials would not be useful in a game engine. These require a little bit more time for the GLSL and OpenGL engine to render out. This is kind of a split. This is a kind of halfway point between using game engine technology but getting a higher result. Okay, we're trading off a little bit on both sides to kind of meet our terms a little bit in the middle, and that's what OpenGL sorts of compositing software does. Especially those that are using OpenGL to make objects, such as Element 3D for After Effects, or HitFilm, and the some of the OpenGL object options that are in that. We could play around with more of these settings to get it just right. Maybe change our point light just a little bit more, some of the energy to get a little bit more of that highlight. Just making that one change gives us a little bit more definition in there. So anyway, you get the idea how this is done. Now what we would do is we would move this around in space, set it in our scene. Oops, that's not what we want to do. Control Z. I just moved my light out of the way. We would move our object around in our scene and place it where we would want. We could also then create particles, a particle system of asteroids inside of our scene. And we could just apply this exact same texturing to those particles, and we could come up with the same sorts of results that we see in our planet output. So all these are particle systems with one object, another icosphere with some modifiers applied to it to create sort of this sort of I don't know, a potato-y looking object that can stand in for an asteroid, and we just apply the exact same materials and it gives us all the same lighting. Now one trick that I applied here, and we're not going to do it, but I'll explain it here if we open this up bigger. Over here where you can see where these asteroids are kind of in the shadow of our planetary object, I just added a point light. And remember that we have that light mask material in the scene. If I apply the light mask material to these asteroids in the same way, wherever I place a light, it will generate shadow. And if I make a very subtle light point over here, it creates the essence of a shadow casting onto these asteroids over here. So you can see how this was put together. It's just a particle system. We all know how to do that. A couple of cubes set in space. Each one has a particle system with the particles rotating, zero gravity, and the same exact materials that I created for one object applied to these. So you can see what's been done in order to create this scene. Now, one last thing I'll do here, just to show you a couple more options. Let's bring in another. Actually, we'll use our GLSL toolkit. We're going to import an image as planes. You can enable this add-on, import images as planes, so that you could find it in the import settings. But the GLSL toolkit provides it here. We'll add a texture. I have a star field texture that we used in the earlier tutorial. Grab onto this one here. Make it shadeless. Use alpha Z transparency. Import this image as planes. We will rotate it on the x-axis 90 degrees, scale it up. It is a shadeless texture again. And we'll move it back in Y space to give us sort of a background to work with. We can apply a halo sort of atmosphere to this planet. So what we might do is we will grab we'll import another image as a plane. And we'll grab this from my shadeless lighting pack. I have an image in here that looks like this. I made this in GIMP, and it's just a fall-off sort of effect, this halo with a dark center, and then it increases all the way to white with a soft outside kind of glow to it. We'll grab this. We'll import it as a shadeless material as well. And if you remember, rotate this on the x-axis, 90 degrees. If you remember from the first tutorial, we could apply this as a material that adds to our scene. If we go to the Blender game engine, and if I go to the material settings over here, I can change the alpha blend mode from alpha blend to add, and it will now add to the rest of our scene. Now if I select on our camera, you can see we have some alpha transparency problem. Now remember that we have this new add-on. I could parent these and unparent them to an empty to change my draw order, or I could just select my objects that are relevant in the scene. And what I will do, all of my objects here, I will recalculate the draw order using my new this new GLSL toolkit. Okay, so we're now able to do this on the fly very quickly. And now all of my shading is proper. Now the other thing that I could do is that if I'm only dealing with this one object with all of the others, I could just change the blending mode for my halo object, and I could change it to something like in the object settings, I could change it to something like transparent, and it will make this one transparent over all others. Or I could apply the X-ray ability. And if I didn't have a bunch of objects in the scene, I can do something really cool. What I'm going to do is I'm going to snap this to the center of my planet. So if I go to my icosphere planet, and I go to Object Settings, click on, go to Snap, and select Cursor to Selected. It'll put my cursor in the center. Now if I select on my halo, and I go to the Object Settings, and I click Snap, I can snap my selection to Cursor, and it will place it right in the middle of my planet. If I go to my camera view, now what I want to do is on my halo, I'm going to apply a constraint. And actually I want to parent this halo to my icosphere. But I want to apply a constraint, and this constraint is going to be a track to constraint. And it will track the halo to my camera. And what I want to do is play around with these settings until I get it so that it faces the camera. Wherever the camera goes, my halo will follow that direction. You see how this works? Now, as long as my icosphere is not too close to the camera, once it gets too close to the camera, you can see how this will kind of come out of, it will kind of come out of the, perspective here. As long as I don't get too close to the camera, it will apply this halo as if it's kind of an atmospheric effect to my planet. Now, my halo is lit up a little bit too much, this atmosphere. Let me enlarge it a little bit. Oh, wrong thing. Control Z. I have my planet selected. Select the halo will increase the size a little bit. And I'm going to apply to this shading so that we can make it look like this is accepting the same lights as the planet. So we'll go to the texture settings here, and I'm going to apply another texture slot. And I'm just going to use the same texture that I used for my shadow. And we'll apply one. We'll apply another one here. Same thing, texture. And then we'll apply one on the right. Same thing. Which was texture 2, I believe. And that gives us now the same shading that we had before. Might want to change my constraint a little bit because it does kind of bring it off kilter. Maybe I'll change the influence to 0.5. See if that helps us a little bit. That doesn't really help us out a whole lot. Hard to say. Maybe I'll disable my constraint entirely, and we'll just rotate it on the Z-axis. I could, maybe something we could do here is I'll go to my camera, click on snap the cursor to the camera, and let's create real quick an empty. And I'm going to parent the empty to the camera, but I'm going to move the empty back on the y-axis, way back here in space. And we will parent, or rather, I will, on my halo, I will set this track to that empty instead of to the camera, and that might help a little bit better. That looks a little bit better. Okay, so now we can take our halo, scale it down a little bit, and I'm going to go to the material settings for the halo, and we will enable nodes. Go to the node editor. We'll select the halo texture, so it comes back. And now we can add a little bit of color correction to this. We'll add a color curves. And maybe we'll bring down the color a little bit. Go to the blue side and bring it up a little bit. Make it kind of a bluish color. Bring up the green side a little bit. And maybe we'll take some of the reds out of it. Go back here, bring down the color a little bit more, bring down the highs a little bit more. And now you can see what we've created. If we go to the camera view and we click on only render in our display, you can see that now we've created sort of an atmosphere that will follow around our object. Now, this gets a little bit dicey using the X-ray option because if you had other transparent objects in the scene, you would have to use your recalculate draw order tricks to get everything in the right order here. But you can see kind of how this is put together. You might want to delete a couple of vertices around the outside edge here, or mask this off, because you see a little bit of an artifact on the edge. But the end result, once you do some of those things, will get you something that looks like this. So you can see that we have this atmosphere applied to our scene, or our planet, and we have our asteroids set in there, a little bit of a light masking applied to it to get some extra shadow, and we can use this same material over and over again for our asteroids and for our planet. And this is another way to apply shadeless type materials inside of an OpenGL scene. So there are no lights being used in this for conventional lighting. Everything is shadeless except for the light masking. So hopefully you find this type of technique useful. You can use these light masks to create shadows and ambient occlusion and other settings too. It works out really perfectly because this is a spherical object, and the point light has a spherical fall off. So it's just how I did it. And you can see how quickly this will render on playback now. So as this plays back, we could have animation in there, and even the render is super quick. If I render one image there, it's just 1 second. Much quicker than using the ambient occlusion that has been added to the Gooseberry versions, Gooseberry builds that are coming out. So a new trick that you can use, and that's how we accomplish that with the objects in the scene. So we've covered the nebula, we've covered the flare, we've covered the star field, a three-dimensional star field, we've covered the planet, and we've talked about how to do these asteroids, one object as a particle system, a couple of particle systems in place here, and we've now covered the whole scene. So everything that I've shown you can now be applied, and you can create a scene that looks like this. But this is not the end of the series. We're going to continue the series as I have new ideas. I will add more episodes to this, and this will be an open-ended series. When I decide that it's done and we've kind of exhausted all of our options, I'll let you know. But this brings us to the end of this project. You can now put the project that looks like this together. Spend a little bit more time on your light masking, get a little bit more detail in there. But essentially that's how it was created, and that's how I got these results. So again, high definition results with just a couple of seconds of render time using OpenGL and GLSL options. So that's all I got for you today. I hope you find this useful, and I wish all of you happy blending.